So for this video, we're talking about Newton's 3 laws of motion, and they are some of the most important laws in the universe. But spoiler alert, the only other laws of science which are even more important are the conservation of energy laws and the conservation of momentum law. In fact, the only time that Newton's 3 laws don't work are for the very, very tiny, so tiny that you're smaller than a proton or a neutron. You're moving very, very fast, near the speed of light, kind of fast, or if we're accelerating while we're trying to observe things. All other times, Newton's 3 laws are valid. So what kind of questions are we going to answer in this video? We're going to answer, what do forces do to objects? What happens when forces are acting on objects? We're going to answer, how are force and acceleration related mathematically? And if every action has an equal and opposite reaction, why doesn't the Earth move when Sigmund, our helper penguin, jumps? In fact, if every force has an equal and opposite force opposing it, how do we move anything at all? So why forces? Forces relate to everything we do, whether it's rocket science, engineering, biology, or just driving our cars. Forces make things happen. So for rocket science, we need to know about the forces of gravity, either between the rocket and the Earth, or between the rocket and other planets, other moons. We need to know about actions and reactions of the rocket and its thrusters. For engineering, obviously, we need to know about forces to prevent structural failures. And for biology, it's important to know about forces for biomedical engineering, which is creating mechanisms that will help the body when some of its own systems or organs or limbs fail. So biomedical engineering is creating prostheses for people who have lost limbs, or, for example, pacemakers for people whose hearts have trouble functioning on their own. And there's a new subset of biology called mechanobiology, which focuses on how physical forces and changes in the mechanical properties of cells and tissues contribute to development, cell differentiation, physiology, and disease. So before we get talking about Newton's laws, we need to remember some other things that we've already learned in physics. Physics is very circular. We always come back to the same things that we've already learned. So position is where an object is located with respect to some fixed reference point, and it's measured in meters usually. Displacement is represented by a delta x, and delta, the triangle, just means change in something. So if we have delta x, that means change in position of an object. And we also measure that in meters. Velocity is how fast an object is moving and the direction that the object is moving in. And remember, for velocity, the direction is important because velocity is a vector. And vectors are any quantity with a magnitude or a size or some numerical value and a direction.